Great. Okay, well, thanks for the introduction. And yeah, so Gleb and I decided to switch order on this because just kind of like thematically and also chronologically, it makes sense to talk about web workers first. Web workers were released first, then service workers. We're going to get into all that, but sorry for the last minute change in case it's like, I don't know, like really surprising any of you guys. So I got a lot of material to go through, so let's just dive right in. So I'm going to talk about web workers today. Hi, how's everyone doing? Sweet. And so to start off, who am I? They always say when you start off a presentation, you should explain who you are because people want to know, like, who is this guy? Why should I care what he has to say? Why should I pull my attention away from my phone or other, infinitely more interesting things? So I am this guy. That's what I look like. I tend to make this hand gesture a lot. This like, this kind of like, how big of a Subway sandwich did I have for lunch kind of gesture. Or I found it from a Japanese friend of mine. She's not here. She might be running late. She told me that in Japanese they actually have a word for this, and they call this pottery hands. Like I'm working a potter's lathe. Like, so it's funny. It's actually like its own word. This mic might actually stop me from making those gestures, though. But be on the lookout. It should happen, hopefully. We'll see. So I work for Squarespace doing Android and web development stuff. I also, in my spare time, help maintain this library called PouchDB, which is a database written in JavaScript, runs a node in the browser. And I have to start off this talk on kind of a dour note. And I'm sorry about that. I promise it's going to start off low, and then it's going to pick up, and it's going to get high. It's going to end right here. Okay, so it's going to start here and then end here. So, all right, don't worry. So I have to start this off by pointing out that the web has a problem. Now, it's not actually a new problem that it has. This is a problem that's as old as the web itself, but it's an interesting problem. And I'm sure that a lot of you are very familiar with this problem. Maybe others of you less so, but it's useful to go over it and kind of demonstrate this problem to get an idea of what it is. So you can reproduce this problem very, very easily. You can try this at home. All you have to do is just create a website and put a single animated GIF in there. Just any old animated GIF, all right? You guys see that? And then just do any kind of JavaScript operation that takes a long time to run. Just any old long-running JavaScript operation. Like here, I'm doing the dumbest possible thing, right? I've got like this huge for loop that's just doing math.random. And what you'll notice is that the animated GIF just comes to a complete halt, right? Just comes to a grinding halt, just totally stops, right? We hate that, right? Because we love animated GIFs, right? We don't want this to happen to our GIFs. But unfortunately, it's not just GIFs even that this happens to. This happens to just about everything that moves on your page. So HTML5 video, JavaScript animations, CSS animations, interestingly not hardware accelerated CSS animations, but just about anything on your page that moves. Additionally, if you have like form elements on your page, you cannot interact with them while this JavaScript is running. Look, I'm trying to click this thing, I can't. I'm trying to input text into that field, I can't do that either. My page just becomes completely non-functional while this JavaScript is running. It just totally does not work at all, right? And of course, the reason for this, right, as many of us know, is that JavaScript is single-threaded, right? And the DOM is single-threaded. So while the DOM is doing stuff, JavaScript can't do anything, and vice versa. So when JavaScript is running, the DOM is just totally blocked. That's kind of a crazy thought, right? If you actually like let that concept sink in, because if you think about that, what that actually means, what this means, is that every line of front-end JavaScript you've ever written has, at least momentarily, totally stopped your page from working, right? It's true. That's what that means. Like every line of JavaScript actually does this. And it kind of impresses upon you when you realize this huge responsibility that we have when we're writing front-end code, not to just totally break the page, right? Because we can. We have the power to do that. Right? It's a huge power that we wield. So thankfully, most of us know to be responsible with our JavaScript. We know not to write, gigantic for loops like the stupid for loop I showed you. But have you ever made a page or seen a page that kind of looked like this? So watch those animations. So it's not so much that they're totally stopped, right? It's just kind of like they run for a while and then they kind of stop, and then they run for a while and they kind of stop. And like I can interact with the page, it works. I can scroll even, but the scrolling kind of gets stuck, right? Like we've all seen this, right? Like we've all seen a website that does this. And this goes by lots of names, right? We call this jank or jitter or stutter or I don't know. There's this kind of stop motion thing, right? We've all seen this. And what this is this is not one big JavaScript operation that just totally blocks the page for like milliseconds on end. This is lots of little JavaScript operations that add up over time, right? This is death by 1,000 cuts. And to figure out how big those cuts actually have to be to create this janky situation, we can figure it out with a little bit of math. So most screens are set to refresh at 60 frames per second. Right? So what that means is that it's flashing 60 images in rapid succession each second, which gives the illusion of motion. Right? Exactly like this. Oh, help me out, Bulos. What are these called? Yeah. Someone. What are these called again? Flipbook, thank you. Exactly, yeah, exactly like this old-timey flipbook. This is literally how everything works. It just gives the illusion of motion. And 60 frames per second is about the limit of what your eye can detect in terms of like smooth versus janky. So when you drop below 60 frames per second, when you drop to like 55, 50, or especially 30, 20, you really start to notice it. That's where it starts to get this sort of stop motion look, and it doesn't look like lifelike or real anymore. You especially notice this on mobile, where we expect things to be more responsive. If you do the math, if you take 1,000 milliseconds divided by 60 frames, you get this number, 16.7 milliseconds. And what this tells you is that any bit of JavaScript that you run on your page, any like cohesive block of JavaScript, has to complete in less than 16.7 milliseconds, or else you risk dropping frames. Right? You start getting below 60 frames per second. 16.7 milliseconds. That's like nothing, right? That's barely any time at all. I mean, that's 16 thousandths of a second, right? That's like the blink of an eye. It's less than the blink of an eye. And if you listen to browser vendors like Paul Lewis, for instance, who works on the Chrome team, you'll find out it's even worse than that, because if you factor in browser overhead, it's actually more like 10 milliseconds. So you got 10 milliseconds to get any of your snippets of JavaScript done. This is just punishingly tiny, right? Like, how are we expected to make rich applications that run at 60 frames per second? How are we expected to make web applications that can compete with native applications, right? Like, this is where, like, we're used to 60 frames per second on our native apps, right? Our native iOS and Android apps, they all run 60 frames a second, no problem, right? But like that, janky website I showed you earlier, that's the scourge of the mobile web, right? We've all seen that. It's awful, right? This is the kind of thing that leads people to say, like, no, we can't write a web app. It's not performant enough. We can't make it fast enough. Like, we got to go write a native app. I'm sorry. And you know what? I take exception with that idea, because I actually am a native developer. I've been doing Android development for longer than I've been doing web development. I've been doing it since about 2009, and even I don't believe that. I think that the web is capable of solving this problem. I think we just have to reach deep into the toolbox to find the things that we need in order to get the web up to the same standard as native apps. And I've reached into the toolbox, and I found one thing in particular that I think is very, very useful for reaching this target, and that thing is WebWorkers! I hope this isn't GIF overload yet. I really like GIFs if you can't tell, so I don't want any of these to be blocked. So all the JavaScript I wrote for this presentation, you can be sure it does not block any of these GIFs intentionally. What a web worker is basically it's a way to escape this single-threaded environment that we're all confined to when we write our web applications, right? And it's very, very simple to use. Like, it's super, super simple. This is all the code in the world that you need to write to use a web worker. Like, you don't need, I mean, there are libraries out there, there's Webpack loaders and stuff. You don't even need that. This is all you need, seriously. Like, what you've got is on the left, you've got your main JavaScript that runs on the main thread. And on the right, you've got your worker JavaScript. And all it is just message passing. You create a new worker, and you can send a message that can be a string, JSON, array buffer, whatever you want. And then inside of the worker, none of that blocks the DOM. It's a completely separate thread. Inside of that, you can receive the message. You can send messages back and forth. Like, if you're used to asynchronous programming, this is going to be a cinch for you. Right? This is all you need to get this done. Now, of course, I put this slide with code up on here, but looking at code is boring in a presentation. So I like to explain how web workers work using Kirby. What else, right? So in a browser, there's this thing called the UI thread, or the main thread. It goes by many names. And basically, its job is to paint. Right? Its job is to respond to user input and to paint. And this concept actually extends beyond browsers. Like, you talk to iOS, Android developers, they'll tell you about the main thread or the UI thread as well. Like, it's a very well-known concept. And this guy's very, very busy, right? I mean, you'd be busy too if someone was asking you to paint something every 16 milliseconds, right? This guy, he's kind of got his hands full, right? But this poor, overworked guy, like, what are we doing to him? Well, we're sending down our gigantic, like, 500 kilobyte JavaScript app, and we're telling him, hey, you know that painting you have to do every 16 milliseconds? Why don't you just fit in my 500 kilobyte app, just fit it in, do all this other stuff, in the middle of trying to do its painting, your business logic, JSON parsing, AJAX, IndexedDB, whatever. Like, so this is why our web apps start to slow down. And what we'd like to do, and what web workers allow us to do, is we'd like to take this little dude, and we would like to spawn a couple friends, right? We'd like him to have like a few more friends that can do work in parallel to him and not block anything he's doing, right? Spawn them, right? That's what WebWorkers do. And you can actually spawn as many WebWorkers as you like. You should probably keep the number down low because they're not intended to have too many spawn. But you can spawn as many as you want, and they can do work in parallel, and they do not block the DOM. So you have your main thread, it's getting work done, and then its friends are also getting work done, and they don't actually inhibit each other from working. So in the end, I mean, you could end up with an app that looks like this, right? And like, you could have an app where like you've got your main thread doing painting and user input like it normally does, and then you know what? Even like slow Android phones out there, like my phone right here, which you know, people like Jeff Atwood say is just too slow to run discourse on, right? He had this blog post about, you know, single-threaded Android is too slow to run Ember and Discourse, right? Well, you know what? This thing, okay, this thing might be slow, but it can do 4 things slowly at once, right? So you could have like your main thread doing painting and responding to user input. You got another one doing business logic, JSON parsing, another one doing AJAX, another one doing IndexedDB. I'm not saying you need to spawn 3 workers to have a performant web app, but you know, even just spawning 1 is very, very useful. All right, so hopefully I'm doing a good job selling you on WebWorkers. Now you want to know, okay, what can I do with WebWorkers? It turns out a lot. You can do a ton of things with WebWorkers. WebWorkers have access to AJAX, all right? So they can do remote calls to your server back and forth. You have access to IndexedDB, all right? So you can do any local storage that you want to do. That's access to IndexedDB, not local storage with a capital L, capital S, because that's old and janky and synchronous, and we shouldn't be using that anymore. We should be using IndexedDB. And both these things, by the way, are very, very useful to do inside of WebWorker. Believe me, these actually do block the DOM. Yes, even asynchronous AJAX does block the DOM. Asynchronous does not mean free. All right. And if you don't believe me, like just go like do that animated GIF experiment and just fire up like 20 XML HTTP request calls. You will see it. And with IndexedDB, you'll especially see it. I have a blog post about this that's linked at the end of the slides. Inside of a WebWorker, they don't block at all. Just smooth sailing. So a WebWorker can do just about anything that JavaScript can do, but of course, here's where we get into the catch. There is one big thing that they cannot do, which is the DOM. All right. So WebWorker runs on a separate thread, does not run on the DOM thread, so it cannot access the DOM. There's no window, document, none of that stuff. But you know, I got kind of intrigued by this concept a little while ago because I was thinking about this, and I was thinking about how, you know, most of us aren't directly accessing the DOM anymore, right? Like we're using libraries like React and stuff like that, and you know, those libraries all use virtual DOM. And you don't need the DOM to do virtual DOM, right? That's kind of the point. So I asked myself, like, you know, you're looking at this and you're like, well, this is, if I can do all of these things in a web worker, can I run essentially my entire app inside of a web worker? And the answer is you can. And I demonstrated this by writing this app called Pokedex.org. And I encourage you all to go check it out if you want to. It's just at Pokedex.org. Runs best on Android, runs a little bit worse on iOS. I'm happy to explain afterwards why Safari doesn't run so great with this app. But on Android, this thing is practically indistinguishable from a native app. And I really mean that when I say that because I do Android native development. I've showed this to native developers, and they were like, wow, I can't believe this is a web app. And what this thing does is it basically just implements the principle that I told you. Every time there's like a scroll event or a tap event or something that needs to change the DOM, do anything, it immediately fires off a request to the web worker. It's like a hot potato, right? Like the UI thread gets that request and it just immediately wants to get rid of it, tosses it off to the web worker. And the web worker does IndexedDB, AJAX, virtual DOM, whatever it has to do, and then sends the message back and then patches the DOM. And conceptually, it kind of looks like this. This is basically the design of the app. On the right, you've got the UI thread, the main thread, right? On the left, you got the worker thread, or you might as well call the left just app, because that's basically what it is. The whole app is running on the left. Action comes in. I send a message off to the web worker. It does IndexedDB. It does AJAX, whatever it has to do, using PouchDB, local forage for these things. Then it renders the virtual DOM tree. And this is the interesting part, right? It renders the virtual DOM tree inside of the web worker and then diffs against the previous version of the virtual DOM that it had, right? And that diff, that's the expensive part, right? That's the part that's like potentially polynomial that React had to optimize like crazy, and then you know, Ember comes in with Glimmer, and they're like, oh, we've got a version that's slightly faster, right? All these efforts to like shave off precious milliseconds that isn't such a big deal if you're just running it inside of a web worker, right? I'm using virtual DOM for this. It's just a kind of standalone library that implements virtual DOM. Anyway, and then at the end of this diff operation, we have the patch, right, which is like the minimal set of instructions that need to be applied to the DOM. And that you can just send over the wire. It's nice and small. You want to keep it small because that's the one cost you pay with web workers, is the cost of serializing the messages that get sent. But hey, it's just a patch. It's just a minimal set of instructions. So you send that across, and then it gets applied to the DOM. And this works really, really well. Like, I demonstrated this. I got this running on my 2011 Galaxy Nexus, so a 5-year-old phone, and it runs great. It runs at 60 frames a second, nearly indistinguishable from a native app on that phone. It is indistinguishable from a native app on newer Android phones. And this works. I mean, this phone, this is an old phone, it's a janky phone, but it's got 2 cores, right? So it can handle this stuff. And if you still don't believe me that this has performance boosts, there was this guy, Parashuram from Microsoft, who did this great bit of research where he took React and he took its virtual DOM and ran it inside of WebWorker and demonstrated experimentally that he consistently got better frame rates when he ran it inside of the WebWorker than outside of the WebWorker. There's a whole article on this. It's linked at the end of these slides. I'm going to send out a link to the slides afterwards so you can peruse it then. Fantastic stuff. Okay, so that's the WebWorkers are awesome and amazing, and everyone should be using them. Part of my talk. Now I want to get into the challenges because, of course, there are challenges with this stuff. A lot of this stuff is kind of bleeding edge, and it wouldn't be interesting if there weren't any challenges, right? We want to know, like, okay, what's the catch, right? So first off, I'll get this one out of the way because it's barely a challenge at all. Challenge number 1, browser support. You guys are wondering, can I use WebWorkers? What is the support for these things? Support is actually quite good. These things are about 5 years old, I think, was the first time that they shipped in a browser. If you look at can I use, you'll see that it's got nearly across the board support. If you are targeting IE 10 and above, it just works for you, right? And Android 4.4 and above, perfect support for WebWorkers. If you need to support older browsers, it's very, very easy to polyfill. If you want to polyfill, there's some guy named Nolan Lawson who wrote this polyfill that you're free to use. It basically just runs whatever you would run inside of the worker inside of the main thread. It's less than 1 kilobyte, so it's not a big deal to drop it in. And yes, it will, your app will run slower on older browsers, whatever, encourage people to upgrade. This is actually a good time. I wanted to drop this in just because it's important to note, because Gleb is going to be talking about service workers, and another burning question I'm sure you have when you looked at that chart was, what's the difference between a web worker and a service worker, right? Because you know that service workers aren't supported in all the browsers that I showed. Web workers are. Well, it's very simple. Basically, a service worker is a web worker. So there's this nice slide from the Blink team report on web workers, also linked in this presentation, where they show that a service worker and a shared worker both implement this abstract worker type, and then there's also a worker which implements this other type. And there's this thing called a compositor worker, but it's really early days in that thing, so don't worry about that. So basically, a service worker is a type of web worker, and nearly everything I've said so far about web workers also applies to service workers. There might be some slight performance differences because I think service workers might run in a separate process as opposed to a separate thread, which is how web workers run. It depends on the browser, but there might be some slight differences, but the APIs are the same. You can post message to send messages back and forth. It's basically the same. And you can use both of them if you want. In the Pokedex app that I showed you, I was using both service worker and web worker. So, I mean, go nuts. And we got 4 cores to work with. So, challenge number 2. This is a really interesting challenge. So I mentioned that the one cost you do pay with web workers is serializing these messages that get sent back and forth, right? So you can send JSON, you can send strings, you can send array buffers, like which one is best, right? And as it turns out, if you just kind of naively send like JSON, which probably you'd like to do most of the time, right? Just like post a JSON object with a few keys, a few values. This can actually be really, really bad. So this is Malte Ubel, who is the head of the AMP team at Google. And he mentions that so they're really, really interested in web workers. They're working on getting web workers into AMP because of all the reasons that I showed you guys. And he mentioned that on Android phones especially, if you have just a JSON object with 3 keys, immediately you start to see performance degradation. So, and then also the Parashuram guy that I mentioned before, he ran into this as well. So it turns out there's actually a very good solution to this. I wrote a blog post explaining what you have to do. Basically, JSON stringify your messages before you post them. That's all there is to it. So I have this little chart where I show I'm running Chrome, and I'm increasing the message size along the x-axis, and I'm comparing how long it takes to send these messages on average. This is cumulative messages, so I can't remember exactly how many messages I sent. But basically, what you'll notice is that this blue is where I'm just stringifying the JSON when I send it across. So honestly, this is just like JSON stringify, send the string, then when you receive it in the web worker, do a JSON parse. That's all it is. And I'm counting the time that it takes to do the JSON stringify, JSON parse. What you'll notice is that this blue line consistently stays under the red and yellow lines, red and yellow representing the raw JSON object and then a partial stringification. This also applies to Firefox, although it's less severe in Firefox. It's much closer. And then interestingly, in Safari and Edge, it's actually the opposite. So if you really wanted maximum performance, you could like use our agent sniff or something. But Chrome tends to be the slowest here, so I would recommend just stringifying everywhere. And if you're lazy like me and you just want someone to write a library for you, that same jerk as before also wrote this library called Promise Worker that you're free to use. It just implements the thing I just told you, where you send a message and it just stringifies it before sending it across. And it also has a promise shim, so you can basically just communicate with workers using promises, which is kind of nice, I think. All right, so challenge number 3. This is another very, very interesting challenge. So this one came up after I released the Pokedex app, and I got in kind of a heated discussion on Twitter with Pete Hunt, who was one of the original creators of React, and Tom Dale, Ember guy. And Pete pointed out this interesting thing. He said, prevent default makes this technique pretty hard, impossible. Ooh, impossible, right? Like it's a bold claim, right? That's the kind of thing that made me go like, oh man, is he right about this? But actually, as it turns out, there are solutions to this problem. I'm going to explain what this problem is, though, first. So it's kind of a complex problem. I have to actually explain it with code. I'm sorry. I know we hate looking at code on slides, but bear with me. So what he's saying is this, is that if you've got a component, like say a React component or an Ember component or whatever, that lives inside of the web worker, and say you want to respond to a user input like a click, and say that you want to conditionally like do e.prevent_default, event.prevent_default, or not do it, depending on what the current state is, right? So you get a tap, say on a link or something, and maybe half the time that you want to just let the browser open up the link like it normally would, and the other half the time you want to handle it yourself and do some kind of whizzy animation or something. So in a normal application, right, you just got this click handler, and you just say, if I should prevent default, then e.prevent_default, right? As it turns out, you have to do this synchronously, right? The browser does not understand if you do e.prevent_default in an asynchronous context. So in this second example, I'm doing some kind of asynchronous operation, and I got a promise that comes back, and then inside of that, I'm checking and doing event.prevent_default. That actually doesn't work. So that was his point. So if the web worker is living on a separate thread, right, you can't communicate with it synchronously, so how are we going to get around this? Well, interestingly, Malta, again, rose to the occasion, and what he said was, he wrote this blog post, again linked at the end of these slides, where he said, at Google, we've been facing this issue for years, actually. We typically late load all parts of the apps, and that includes implementations for click handlers. So we might not be able to synchronously handle a click all the time, which brings us to exactly the same problem as having the app running in a different thread. So long story short, his solution to this problem is basically, instead of using JavaScript to respond to this, to have just a global listener and then use attributes on HTML tags to tell you whether you should prevent default or not. Another way you can get around this, which is the way that I got around it in the Pokedex app, honestly, is that like most of the time when you're doing this stuff, you're either going to always prevent default or you're going to never prevent default. So just do that in the UI thread. Or you know what, if you absolutely need to have some kind of conditional thing inside the UI thread, just do that thing in the UI thread, I would say. I mean, if you're going to take 20 of your components and you can run 19 of them inside of a web worker and 1 inside of the UI thread, then do that, because you're already 95% better off. My math right? Another thing, workers are constantly getting better. They really are. Like, this is not a dormant technology. This is a technology that has been improving steadily over the years. If you go to this Mozilla page that they have, it's a beautiful page where they say APIs available to workers, and they list all of them. They just list any API you can think of, and they tell you whether it's available in a worker or not. And if it's available in a web worker, it's almost guaranteed it's available in a service worker as well. So just it's available to workers. And what you'll notice when you look through this list is that not everything is in there, but things have been slowly added. So for instance, I mentioned IndexedDB inside of a worker. That wasn't available inside of Firefox until recently. It's still not available inside of Safari, although you probably don't want to use their IndexedDB anyway because it barely implements the spec. It does work inside of Chrome, or Chrome and Edge very, very well. But you'll notice that Firefox has been catching up on a lot of stuff. Until recently, you couldn't even do console inside of a web worker in Firefox. You couldn't console.log or anything like that, but now you can. And some of the stuff that they're adding recently, they've been leapfrogging the other browsers. It's been amazing. Like one thing they added in the last version of Firefox, this is incredible, WebGL on a worker thread, right? So you can do, in Firefox right now, you can actually do WebGL inside of a worker thread, right? So it just does not block the DOM at all. And then following up on this, they're doing something that is even cooler. Well, in my mind anyway, it's even cooler because I immediately know what kind of things I want to do with that, which is that they are working on bringing Canvas to web workers. So image resizing, converting between PNGs, JPEGs, all that stuff, image manipulation. You'll be able to do that inside of a worker. And that's, as far as I can tell, based on this, the activity on this Mozilla bug, it is slated for the next release of Firefox. So really, really exciting stuff. Workers are just improving all the time. And in general, what I want to leave with talking about all this web worker stuff is that I think, so web workers have kind of been around for a while, right? They're kind of 5 years old. And sometimes when you look at this tech, you might think to yourself, like, well, if it's 5 years old, why is nobody using it? And what I would say about that is that, sometimes it just takes a while. Sometimes something is an idea whose time has come, Like Ajax was released in 1999, right? We forget this. IE5 pioneered XHR, right? It was released in IE5 in 1999, and the Ajax revolution came about in 2005, 2006, right? Sometimes stuff just has to sink in for a while, or it has to reach a critical mass of browsers. And I believe this is the kind of technology that's going to start appearing in frameworks in 2016. And I've seen a lot of signs that this is happening, a lot of positive signs. So for instance, Angular 2, this is the big one. So Angular 2, already out in beta, I believe. It's not released yet, right? It's still in beta. Yeah. And this is actually where I got the idea from. I have to give full credit to Angular 2 because they're the ones who pioneered this stuff with WebWorkers. I shamelessly stole my ideas from them. I saw this tweet from Brian Ford, who's on the Angular 2 team a little while back in September of 2015, where he said their idea in Angular 2, and they actually are going to make this possible, their idea is to basically run the entire Angular app inside of a WebWorker and then send rendering instructions over to the UI thread. And they have an excellent series of videos, again linked at the end of this slide, where they explain how this all works, and they demonstrate before and after of like, here's a version of an app with WebWorkers, here's a version without WebWorkers, and they show how much smoother it is, how much crisper it is. So props to the Angular 2 team. This is an amazing piece of work that they've done. And other frameworks are taking note as well. So even Pete Hunt kind of came around and he said, "Wow, running your whole React app in a web worker, it could be worthwhile." So this was just a little while ago he said this. So I was pleased by that. Inside of Ember, there's been some work done by this guy Chris. He's Runspired on Twitter. He's been working on this plugin for Ember called Skyrocket that helps it run inside a worker. He's been doing some great research on web workers as well. And I've also got some positive signs from Tom Dale. I just love this quote, so I have to drag this out. After I did the Pokedex app, he said, "It's like Nolan Lawson dragged us all into a time machine and showed us how all web apps are going to be built in a few years." So I was very pleased by that comment. In the app, I made use of service workers and web workers, by the way. So I think both of these things are kind of this powerful idea that are coming together at just the right time. And I'm going to leave this with a quote from Jake Archibald from Google, where he says, "Prediction, the next generation of JavaScript frameworks will be server first and mostly in a worker." Because we want server rendering, right? We want that quick initial rendering of our content, but then after that, we want to put things in a worker so that it can run at 60 frames a second and the DOM is not blocked. The user experience is not blocked. He might be talking about service worker here, because he's the service worker guy, but I don't really care, because the service worker is a web worker, so I think that's beautiful too. You should be using both if you can. So please, this stuff is going to be coming to frameworks. You can play around with it there, or you can just start using it right now. It's very, very easy to work with. So please, let's start using web workers and service worker, and let's take our apps that look kind of like this, and let's make them look like this. Thank you.
Just interested in the virtual DOM patch. Like, can you just talk a little about what that looks like?
Yeah, sure. You're talking about way back here, this slide, right? Okay, so virtual DOM has 3 phases, right? You render a DOM tree, right? A virtual DOM tree. And that's the first phase, the rendering. The second phase is the diffing, right? You diff that tree against the previous version, right? The previous virtual DOM tree, right? And then the third phase is that you take that diff and you apply it to the DOM, right? So what I'm pointing out here is that everything that I just said, you notice there was no DOM in there until the third step. So out of those 3 steps that we're doing inside of virtual DOM, you can do 2 inside of a web worker. And experimentally, like at least I've found, I think you'll typically find that the second step is the big one, the diff. So does that make sense?
Does it take a lot? Thank you. Does it take a lot of like planning to do? Or, I mean, do you have to think about a lot of? Are there a lot of things to consider to do that correctly, or?
I found it pretty simple in the Pokedex app. Yeah, I mean, it's as long as you're comfortable with asynchronicity, then it should be pretty doable. I mean, if your app is already optimized for situations where, like, I don't know, constant messages are coming in asynchronously via, like, I don't know, WebSockets or XHR or something like that, then if you're already thinking asynchronously, then it makes it really, really easy to do this kind of stuff. But part of the reason, I will admit, part of the reason that I used the virtual DOM library, it's just a standalone library called virtual DOM, was because I didn't see an easy way to kind of shoehorn this into an existing framework like Ember or React, but as I showed, others already have, so it is doable. Versus calling, oh, that's a good question, yeah. So you may be curious when I mentioned kind of offhand, right, that it is useful to do Ajax and IndexedDB inside of Worker because it can block the DOM. And believe me, I've seen this so much. I've seen people like using PouchDB, for instance, at the library I work on using IndexedDB, and they say, my app's slowing down all the time. I'm like, well, did you put it inside of WebWorker? No. And the reason for that, I talked to browser vendors, and basically it's that There's things like structured cloning. There's things like events. There's like in the case of IndexedDB, for instance, if you're doing a transaction, there's lots of stuff you're doing inside of that transaction that is synchronous and takes up time. All of those things add up. And the best way to see this, honestly, is just like I said, like do a bunch of AJAX requests or a bunch of IndexedDB requests, and then look at the profiler in Chrome, and it'll show you all the stuff that's going on the main thread. And there's plenty of stuff going on. Like I said, asynchronous is not free. I'm not a browser vendor, so I don't know all the nitty-gritty details. But I did talk with like the Mozilla and the Chrome team, and they mentioned that there's only so much they can do to get that stuff to not block the DOM.
And then regarding the native app development, have you ever mixed the worlds where you're using web views and using web workers maybe in your native app? And if so, any concerns, roadblocks, benefits?
Yeah, there actually are some good reasons to do that. It definitely is going to be dependent on what kind of app you're writing, but I can think off the top of my head right now, a good example is if you're working with data in a web view on Android, I would strongly recommend using IndexedDB or WebSQL, or you can't use WebSQL inside of WebWorker, excuse me. I would recommend using IndexedDB inside of a WebWorker because when you use Cordova, for instance, and you're sending messages back and forth between the native environment and the web view, that has to be serialized, and that you pay a huge cost with that. Like if you're using something, if you ever tried something like the SQLite plugin, and you compare the performance of that to the built-in WebSQL or built-in IndexedDB, like you'll see a huge difference. I don't remember exactly what it is, but it's definitely like an order of magnitude, especially if you're sending lots of data back and forth between the web view and native.
Hey, well, hello everyone. I don't think that in New York or especially at Spotify you see this logo very often, or you even hear Workers of the World Unite. And I didn't know the screen would be that low, so otherwise I would put web and service workers. That's what I mean when I say workers of the world. And I don't mean the world, I mean the web. Anyway, about me, I asked my parents before I was born to give me a unique name so I could get my handle on Twitter and my website, so they obliged. I work at Kensho, which is a financial startup. We're pretty successful. We are right in the middle of this building, and we're right in Harvard Square. We're definitely hiring, so if you're smart, definitely talk to me and make me feel dumb. Anyway, so we built a huge Angular web app. That's our bread and butter. That's what we sell to the clients. And at some point with Angular 1, we hit performance bottleneck, which was a good problem. That means we had a lot of data, a lot of users. And we started investigating, and I kept updating and writing and expanding a blog post about solving Angular 1 bottlenecks. And at some point in 2014, it was #1 if you just do Google AngularJS performance. And it is still #1 on the second page. So if the way I see this, that a performance for a web app has really two parts, right? There is the initial performance, right? How long does it take to actually start it up? And there is a second part is running, right? You want the junk-free, fast, snappy, responsive operation. And I'm not partial here, but I think like this one is slightly simpler to solve right now using the modern technology. And as Nolan showed, like WebWorkers offloading, the expensive computation that blocks the main thread is one good solution. My rule of thumb is like don't try to do too much. You have 16 milliseconds. In reality, you have 10. So don't run a huge computation inside your main thread. So that's it. Don't try to do much. Anyone knows how hard it would be to solve the problem of what Nolan has shown solved? It would be me, because at some point I stuck like part of Angular 1 digest cycle into the web worker, and then I was like, well, I stuffed the whole Angular 1 into web worker, and I tried to do virtual diff updating, and I failed badly. So just the fact that Nolan actually stuck to his guns and made this possible is back to reality. So the question I'm trying to solve today, or show my solutions to that, is how to start the web apps quickly, right? And we all know that we should like parallelize downloads, we should use CDN, we should minify, we should use small images, the most important one, right? We all talk about JavaScript, right? It doesn't really matter. Like 85% of a download for regular, like typical website are images, right? Whatever you do with your JavaScript, doesn't really matter. The images will kill you. Separating, above the fold versus the rest, and things like that. Nice things. So let's look at typical application startup. So you load HTML, right? That's the kickoff. And then you probably load in parallel JavaScript and CSS, and the browser can load like 4 or 5 resources per domain in parallel. And then it loads a framework. Some frameworks are large, some frameworks are small, but the framework itself has to load. And then you can load the app. The app could be large, could be small, but it has to load before it can do anything. And then the app usually gets data from somewhere. And then it draws the data. That means it actually puts it in a DOM, and then the browser renders it, and then the user sees something. And if you draw a line like right about here, then the speed of this part is usually not directly your responsibility, right? It's the ops guys, right? Do they use CDN? Do they configure it correctly, right? So you usually cannot control this. You can only control this part, the app code, and what it does. And then, what kind of, how you use the browser. Usually, there is also a caching boundary. So the browser will actually cache by default for you everything here, like all the resources, right, will be cached. In this case, how you get the data, do you cache the data, when do you clear the cache, when do you request, how do you update, and how you actually put the data into the browser is up to you. So you really control these two parts. And this part, loading the app, compiling it, right, starting to execute it, getting the data, putting the data into the DOM and rendering could be very, very expensive, as we both know. So flame charts, right? So a typical app, in this case Angular 1, processes a bunch of templates. You look at the flame chart and it's like a rug, right? And it takes, in this case, almost longer than half a second just to evaluate the app. And then the tiny part in gray is actually the painting in the DOM. So think about how much stuff your app does on startup. You take different framework, right? As an offer, you probably can switch the app to something else and saying, well, by default, React is faster at boot time. And you can argue that, during runtime, you can make your Angular 1 as fast as React. And I would agree with you, I can make it as fast. But at boot up, Angular 1 usually is slower than React. And you should use flame charts to actually look how long it actually takes to start. Here's my example that I will show. Instead of animated GIF, I use PivotalTracker for all my kind of reading. Okay, loaded, right? It's a simple to-do list. Okay, let me reload. I haven't done anything, right? It's my personal project. I have not changed anything. I just reloaded the page, and I had to wait. Pivotal actually is pretty good software. Like, I love them. It's reliable. It works well. But the fact that, I spend a couple seconds just waiting for it to load is kind of mind-boggling, because the data has not changed. It's completely on the developer who wrote the app to mess this up, and they messed it up, in my opinion. And also, one point that I want to kind of use to my advantage as an offer, if I load the page, the user cannot be quick enough to interact in like first 500 milliseconds, unless it's some kind of bot, right? But in the majority of cases, as a human, I first have to read, understand, oh, what am I looking at, before I start interacting. So I have a little bit of leeway when the page can actually become responsive and start processing clicks and scrolls and so on. So the question is, why am I waiting, especially for PivotalTracker? So time to open, what is in this case, timeline, reload the page, and just like every startup, right? They put nice message, you're looking at our stuff in a console, right? Which is beautiful. Like they have a logo, they have a little bit of shadow. Like I like this. Like this is nice. But then they spend almost 5 seconds scripting. It's a to-do list app. They spend 5 seconds every time you load them on scripting. So I try to understand what's going on there. I open, sources, and they have a single JavaScript file that they minify and put there. And of course, my MacBook Air just dies on that file, okay? And Nolan, you mentioned like 500 kilobyte app, right? So very single JavaScript app is 2.5 megs, right? To-do app, right? It's not graphics, right? It's Webpack app, I think. So they have a bunch of exports. They have jQuery. Originally, they were backbone apps back in the day. Now they actually have React as well. So they pack both frameworks into one. I think they're transitioning. So in the meanwhile, they're running both. And I think that's part of a solution. But this size is just huge. This size tells me that I could actually go work at Pivotal, and I would not be the worst one. So personally. But they use pair programming at like 100% of the time, so I could never do that. And again, I'm not mad. Like, I still use the app. I love it. I'm just disappointed. So one of the things that I want to take away is that I haven't changed the data between the reloads. So how come the data is not cached? How come it's not available right away? So always cache your data locally, I think. And then check for updates. I actually like how Twitter does it, right? You reload the page, it appears very, very quickly, and then shows like, oh, you have new data. And then I can, as a user, select and actually scroll. Even more frustrating than waiting for data is when there is some data, like a static part of a page. Let's say, application loads, right? So it has some footer and header and maybe a menu. And then the app starts, right? So first, I'm looking at something. And then the app loads data and it updates the page immediately. So all of a sudden, I was looking at something and everything shifted, right? The footer disappeared, whatever I was reading changed. This happens a lot on mobile when the images suddenly appeared and whatever I was reading just violently shifted like 1,000 pixels below and I lost myself. Or even worse is when usually this happens on trying to connect to wireless on Amtrak. So you try to click like, yeah, accept that button, but the button disappears because the logo image all of a sudden, and I click instead of accept on like read the rules, right? And then the rules take forever. So I cannot go back because if I click cancel, I'm like canceling the Wi-Fi connection. So anyway, this sudden change is really frustrating, and the fact that we're still doing this is just mind-boggling. And here's an example, and let's see if we can just show it live. So I have a little app, and the little app is running a framework called Vue.js. And on purpose, I slowed down the framework initialization by 500 milliseconds, I think, or 2 seconds. It will tell us, I think. And I have a to-do list, just like Pivotal. And if I reload the page, right, boom, it loaded, right? So this kind of shows the behavior. And, I can interact and everything, but every time I reload, and the data is stored in local storage. So this is an acceptable behavior. Just the fact that it violently shifts is a bad idea. So let's start coming up with solutions. And I haven't said service worker yet, right? So you guys like, what is this guy? Wrong slides. I will not get to the service workers until like 75% maybe, because I want to explain like what the solutions could be without service worker before we actually see how service workers solve it and how nicely they solve it and what else we can do with service worker. Okay, so just the last part of loading a page. Everything loaded. Now we actually started running. So we load the app. It loads the data. We render HTML. It updates the browser. We see something. So we should cache, right? We should cache the data. I mean, the app, usually done by the browser. We should cache the data. It's on us. How about we actually cache HTML? So everyone says, oh, use server-side rendering. As an app author, you have the rendered application that's specifically tailored to the user running it because you already rendered it once before, right? If you're reloading the page and you're not reusing the already pre-rendered HTML, like you're pretty much wasting it. There is no even a question of frameworks. Every framework can actually render inside the browser. That's why it runs inside the browser. So why don't you cache the HTML rendered once? And then on the next load, you just put it there and then initialize and make the app live. So that's the idea. The idea is, again, same data should lead to the same HTML. So if you put the HTML first, it will not change violently the next time. Okay, so previous load the data, app updates a page, we save the data in HTML in local storage. Could be asynchronous, more modern storage, but it doesn't really matter because the way we use it is synchronous later. We load it the next time. We take the HTML and the data from local storage. We put it on a screen, and then we continue as normal. I call this process hydration, just because there is a concept of server-side rendering where you get HTML, but it's static, and then you start the app, and it hydrates that static HTML, and it continues. So kind of the same thing. And here's it's in action. So again, the application is actually delayed, but notice that the list appears instantaneously, right? Yes, it's a static list, and I can, add, finish slides, but it appears instantaneously. This is what Pivotal should have done. And let me just show it here in the center so that everyone can see. Again, this is a static thing that we see while application is loading. I cannot interact with it. But probably I will not be able to even that quickly start interacting with a page that just loaded. Okay, so in this case, it's view.js. The library is quite small, but it works with any framework. Pretty much any framework can continue working either starting from a static HTML and just update it, right? Like React can do it. Or like Angular or Vue.js, you can bootstrap and start the web app in a separate hidden DOM element while showing this static HTML. And then when the application is ready, you just switch them. And you take the static content away, you show the actual web app, and it should probably look the same because it starts from the same data, and then the application will just continue. So works with anything, or works with everything. All you have to do, take the div, that's your target, your placeholder, and then load that library, hydrate app, and tell it what div to target. And there are only two methods, really. Like the simplicity is just because it's hydration, you have to come up with a funny name. I used the name called bottle. So once your application starts, it can say bottle drink. That means take over, switch whatever you had before. Every time you redraw, right? Like, let's say I have a to-do list and I added new item. I have to tell my hydration, hey, my content for next reload is this. I just updated. So whenever you want to save a checkpoint, you have to call bottle refill. And the hydration script will look inside the div, grab just the HTML, store it in local storage. Should be minified, but who cares? So only two methods, and it works with every framework. What is this? Oh yeah, so explanation is in pictures kind of like this. As soon as HTML loads before anything else, we put the static old version there. App loads the data, should be the same data. Renders HTML, renders either in a hidden div or could actually hydrate whatever static we had, and then boom. I mean, in this case, renders separately and then replaces, and everything goes. So I call it progressive web app for 5 cents, right? Because the price of this hydrate app library, it's really like 20 lines of JavaScript minified. Like even on a mobile connection, it will cost you like 5 cents to actually download and start using it. So really easy to do. The links. Okay, and once I'm actually using it on my website, so I can show you in practice. So my website has a web app. So the top content is static. The bottom page, I mean, this huge list is dynamic. So the web app actually renders. So if I reload, it actually comes out very quickly, right? Even though it's a giant list and the app, has to run. But because this little hydration has to get the local storage and then set the static content, you still see it, right? Because this tiny pause, like I'm loading, oh, stop, grab new one, set it, and then continue, is noticeable. And it's not as good as like completely server-side rendered app. And I'll show the difference. So at this case, let's see if I have sound. Oh, I don't have a sound. Okay, ready, set, go. Let's try it.
I appreciate you coming down here, Mrs. Parr.
What's this about?
No, it doesn't allow me
Has
to
Dash
control
done
it.
something wrong?
He's a disruptive influence.
Okay.
And he...
I just want to show this video because it exactly explains how other people look at me or looked at me when I was showing that problem. And it's like, oh, but it blinks. So I implement the solution and I kind of tell people, oh, look, like it works very well. It cuts down from 5 seconds to like 15 milliseconds, but you can still see it.
I appreciate you coming down here, Mrs. Parr.
What's this about?
Great sound.
Has Dash done something wrong?
He's a disruptive influence, and he openly mocks me in front of the class.
He says.
Look, I know it's you. He puts thumbtacks on my stool.
You saw him do this?
Well, not really. No, actually not.
Oh, then how do you know it was him?
I hit a camera. Yeah, and this time I've got him. See? You see? Oh, you don't see it?
So a little trying to like, see how it blinks? Like this part doesn't blink. But
Wait! Right there! Right as I'm sitting down! I don't know how he does it. But there's no tack on my stool before he moves, and after he moves, there's a tack. Coincidence? I think not!
Bernie.
Don't Bernie me! This little rat is guilty!
You and your son can go now, Mrs. Parr. I'm sorry for the trouble.
You're letting him go again? He's guilty! You can see it on his smug little face! Guilty! I say guilty! Guilty!
okay, so I tell people, look, it blinks, right? Like the top part arrives right away, and then it blinks, and then the rest shows up, and they think like something is wrong. But then I show them the server-side rendering. So in this case, here's a little to-do MVC app, and I'm using free Heroku Dino, so it doesn't come out right away first time. Okay, so the page appears. I already like reload the page, right? Like it doesn't move. Like it's so fast. The fact that this page, right, that has no JavaScript. So if you look at the top, I don't allow any JavaScript to actually run on this page. It's a completely static page. I can turn off JavaScript and it will still run. The fact that it arrives from the server, but to be honest, it's somewhere like close, because it's, I think, Amazon 1. But the first paint is at 270 milliseconds, and the whole page appears instantaneously. Like, this blows any web app. The whole experience without any blinking is just mind-boggling. And it's safer because there is no JavaScript. And the fact about browsers is that no matter how much HTML and styles and CSS effects you throw them, they're actually very, very good and fast at rendering static HTML. Like really good, like exceptionally good. What actually stops the browser from being very fast is JavaScript, nothing else. They can take megabytes of styles, apply it to megabytes of HTML, and your page will appear, in a blink of an eye. Like this is unbelievable. That's the experience I want to get to, right? Like with that hydration and like replacing part of it, I could not get to that. It still blinked. So if only we could take a web page that's dynamic, and if we reload, if we could give a browser a full page, not to partial page and then reload part and then give the rest. If we could actually form the full page and give to a browser, it would appear very, very quickly and without any blinking artifacts. So finally, service workers, right? So we went through this problem and a little bit of an obsession to one solution, but then the new technology appears, right? And it's a little bit different from WebWorkers. So we have a browser tab, and it can have multiple WebWorkers. But it can have only a single service worker. And multiple tabs for the same website will actually share the same service worker. So if you have 20 tabs, like you will actually see the slowdown in performance, and a huge one, because everyone is trying to get onto the same kind of loop. But it can do some amazing things that no web worker can do. It can actually intercept a request, and it can transform the request or not, and it can send it somewhere else. So imagine you have a full proxy, right? Like everything we do, and we're like, oh, we're hitting like cross-site, course restriction. The first thing you do is like, I'll have my own proxy server, and that will solve everything. Well, imagine we give it to you in the browser. That's what Service Worker really is for my purposes. Okay, so request goes out, hits the server sends something back. We intercept response. We can transform or not, and we can give it back to the page. So it's really, really interesting. And people actually, the most common use is very, very smart cache. So app cache is dumb and hard and really unusable. You can implement a smart cache that can, for example, do offline first. Like if you already have something cached, return immediately, and then check for new version and update your own cache, things like that. You can do image or video transcoding. So you can send the smallest WebM, WebP image and then transcode to JPEG or whatever browser accepts. Offline support is huge. You can even get background data sync, right? So the server can actually send push requests or date, whatever it is. It's so new that nobody is using it yet. But you can do it. And just getting one service worker for your website is extremely easy. Just like WebWorkers, you just say register, the script, and then the scope. And the scope is what subset of your website should the request be intercepted, right? So for example, you can have one service worker that just caches like data requests, but nothing else, right? And you can have multiple hierarchies. And if you do that, this already works in Chrome and Opera, even on Chrome mobile without any flags, just boom, goes. Firefox, you need, I think, 1 or 2 flags. I forgot if the second, no? It's on by default now, excellent. But you need HTTPS, right? Everything that's not localhost, HTTPS. And the reason being is that if your website allows someone to intercept a request, you should be pretty sure who that is, right? But someone malicious doesn't intercept it by injecting the JavaScript and just says, hey, attack in the middle. And inside the service worker, you use self just like inside the WebWorkers. And you have install, activate like lifecycle events, messages so you can receive messages, send things back, push for server push events. But the most interesting event is fetch. So fetch means that the page is trying to get the data using AJAX call, and that's what you intercept. And so you get URL, and you can respond with something else or allow that fetch to continue. It's all promise-based. And if we compare like environments, like what features the browser has versus WebWorker and Service Worker pretty much has everything just like WebWorker. But it doesn't have even AJAX. So the old AJAX is gone. You have to use the new fetch API, which poses a problem, right? So a lot of browserify kind of webpacking things, they still rely on XML HTTP requests to recreate this, right? So they will not work by just browserifying. It will not run in a service worker because the service worker doesn't have HTML HTTP request. And the promises for everything, right? Everything asynchronous, nothing really breaks stuff. Stop stuff. Let's do something fun. So I had that hydration library that inserted, the static thing into the app, allowing the real app to kind of bootstrap. So I wrote bottle service, and it's a service worker that will keep whatever static content I want to have, right, for the next load. So it just sits there, and browser sends a request for a page. It goes to the server, no modifications. The server will actually give like kind of static, typical application, but doesn't have anything inside the div for the app, right? It will say, well, the browser will actually start the whole web app stuff. So this goes to the service worker, which inserts this fragment into HTML. So it actually forms the full HTML already preloaded and sends it to the browser that just displays it. And this time, it's not partial page. It doesn't have to be updated. The full page arrives. It's static, but your web app can then start. And it actually looks pretty nice. And the code is very, very simple. So you listen for fetch event. And then you respond, and you actually fire the request to the server, so you allow it to continue. Once you get the response, you merge HTML, whatever you have cached, whatever comes from a browser, put it together, and then you send a response object back. That's it, like really simple. Again, free Heroku. First startup is slow. What's nice about Heroku is that every time a dyno goes to sleep, it actually destroys all the saved data. So people, try to post like overwhelm it, but it just gets destroyed. So see, there is no blinking whatsoever. This little check marks the CSS, and they actually arrive later. But the content of a page, as you see, is absolutely like it's ready, and it's actually combined with my dynamic content. So I can modify, but my reloads are instantaneous. And just so you don't think it's small, it's actually a huge list. And so this is all static part, and then the app. So this thing is something that the app said to the bottle service, hey, cache this for me, and next time insert into the page before you actually give it to me. So this is all my user content that I see in the middle. So that's how the page arrives to my browser, fully formed on the first load, almost instantaneously without any blinking or artifacts. So bottle service, which is nice. But then you look at what's happening. And so my page is making a request, goes to the service worker, goes to the server does something, generates result. I intercept the result, maybe modify it, and then I send it back to the browser. If I look at the request and response objects, it's a part of HTML5 API specs, right? So you can look at request and response. But really, what can be there? So request will have a URL and maybe accept and some headers. And response will have a body and some headers. So it's very simple to actually work with these objects. And let's say I have Express server. And like any Node.js thing, it actually uses something from module called HTTP. So it uses HTTP client request, and it has URL, method, some headers, maybe a body. And then it gives back HTTP server response, which has, body, headers, pretty much the same thing. And I was thinking, the inputs and outputs are very close, and the logic in both parts is pretty much JavaScript, right? Like, yeah, I get the data, but even like regular Express servers usually gets the data either from database, or it actually makes a HTTP request, for example, to a backend that gives me the data. And so what I thought was, well, forget this. Let's just take the whole server, browserify it, and put it in the service worker. It's all JavaScript. It takes it takes request, does something, gets the data, puts it in the response, and sends it back. So why the whole, trip? And we can adapt a request to client request, whatever Express desires, and we can adapt the response object so that when Express code is writing something back, it's actually writing in a HTML5 response. And another thing that was really interesting, if you go to NPM registry, right, and there are millions of packages, but most popular ones are Browserify and Express. So by taking Browserify, applying it to Express to stick it into Service Worker, you're actually marrying the most popular technologies of NPM universe. And this process of taking Express or Express app, right, that like does require something else, require middleware. Like if you install Express server, I think it's like 800 packages, right? But if you call Browserify and then you have to do a few adjustments, right? Because there's no HTML, HTTP response or request object. So you have to kind of tweak the output just a little bit, it's actually not that bad. And I wanted to use a GIF of like some like monkey like knocking with a hammer on on a huge machine. It's actually very, very simple. It was very straightforward, so I can even use a GIF or something. Kind of looks like this. Take express. When you intercept fetch request, adapt, and then call the app, right? The whole middleware with this new mock request, mock response. And just a quick question: who uses TypeScript here? Just a few people. Okay, so if you use TypeScript, you would never be able to do mocking like this, right? Like hacking and saying, oh, it will have pipe, don't worry. Oh, unpipe, oh, it's just empty function, doesn't really matter. The fact that JavaScript is so flexible and will accept everything that I throw its way, and if it crashes, well, I'll just add the parameter that I missed. Like, I would never be able to do it in TypeScript, and that's why I'm not a big fan. Okay, so let's see if it works. As always, Heroku, free dyno. So, okay. Can I delete things? Don't do that. Here's something interesting about this page. Let's look at the tools. Reserve log, because I'm reloading. So the page arrives from a service worker, right? So there is no extra trip. So the service is actually running in a service worker. But another interesting thing is that if we look at this page, it still has this tag, but it doesn't allow any JavaScript. Right? So I banned JavaScript from this page. And this is interesting because if I go to the tools and I'm security conscious, and I say disable JavaScript, right? How does this look without JavaScript? Interesting. All right, I can delete. So my page runs with JavaScript disabled. Does it still run with JavaScript disabled? Or did it go away? No? So this shows that once you load Service Worker, you can disable JavaScript client-side completely, and it still works. And this is the amazing thing, right? You think like you can disable JavaScript and you'll be like all like Richard Stallman, safe? No. Where's the way? But you think, well, I still need JavaScript enabled to actually load the service worker once. And by the way, speaking of DevTools and service workers, once you load service worker, it's really hard to actually unload and stop it. It's like this path that just sits in your system, and you have to go to a special Chrome service tab. And then you have to stop and then register and reload everything. And it's really tough to actually get rid or even update the version of a code. But there is a proposal to load service worker just like this, like link and relate, I guess relation service worker, give it a scope. So just like style sheet. And in this case, service workers will take over the world because there's no way to stop them. Okay, last part, 2 minutes. The title of this presentation was Workers of a World Unite. So far, Nolan has shown web workers, and I've shown service workers. Where is this like unite part? So there's difference in environments, right? What objects, what APIs are exposed to each, but it runs on the same JavaScript engine, right? It's not like there is like separate V8 for service worker. So what you can do is interesting thing. I wrote Babel service. So I wrapped Babel transpiler and ES feature tests, again using Berserify, stuck it into service worker. And so if I have a request for worker that goes unchanged to the server says, well, I'm using this destructuring with default arguments, right? Because I'm hip, I'm modern. I don't want this transpiling bullshit. Like the fact that I can just make my ES6 code look like this without any transpiling is huge for me. Okay, but this goes back, And now, inside this, I look at the features used inside that code. Well, in this case, destructuring default arguments. And I can selectively transpile only the features that I'm missing. Not everything. I don't take the whole code and put it to make it ES5 or ES3, just with missing features. So for example, the browser that doesn't support destructuring or default arguments can get something like this, right? Which is typical transpiled code. But a modern browser, like Chrome Canary, will actually get that code unchanged. And this is huge. Because once you start debugging that, you're like, oh, this is my original code. I can step through it, everything looks nice. Let's see if we can actually see this in action. So this demo will request just a small piece of JavaScript, and then I can use it, for example, right? And it actually shows it at the bottom. So in this case, it was transpiled, because Chrome doesn't support default arguments in this case. Okay? If I take the same code, I have Canary, and I load it here. Just when you think everything is going great, and I promise you everything is. Okay. Let me kill this because this is. I'm not sure if I'm saving actually the results of tests. Okay. Boom. So the code that this allows the browser to receive is completely untranspiled because the Chrome Canary already has everything turned on. And that's why I'm not updating my regular Chrome, just because I wanted to show the difference. Also, and it was really hard to make this demo because the Chrome is almost up to date, right? And so if I picked a browser that supports ServiceWorkers but doesn't support some of the features, it's really hard to find that one. Okay, so it works nice. So that's the marriage. Almost last slide. People to follow, Jack Archibald from Google. He's the guy responsible. He has excellent links and tutorials and shows some amazing progressive rendering of HTML by hacking the streams into the service worker and what it returns. So he's just awesome. Matt Gunt, also at Google, not surprisingly, also has very nice blog posts and demos. And this guy has done everything that you've seen so far. So try to follow me. And thank you very much. The slides are there. Thank you. Absolutely. So this is a security nightmare only comparable to Internet of Things security nightmare. Because once you install it, right, it's really sticky. And so if you, for example, define the scope of a service worker to be wider than what you actually intended, right? Let's say you want to use service worker for only dynamic app, but not for admin path. It's really hard to get rid of it, right? So right now the security will be, like, you have to pick wisely, maybe start with very narrow, part of your website. I think it will be the worst for people who host one domain, but then allow multiple sub-apps, and then not checking what runs on a root domain, and then someone can intercept everyone else's requests. You really have a power, right? And with power, I think that everyone who uses or programs service worker should apply for a license from New York State and then get permission. Yeah. Oh, from browser vendors like Chrome, yeah.
Other same origin restrictions on
I don't
that?
think so. Oh, there is one. Yeah, okay.
geocities.com/app1, and then you serve the service worker from /app1. It can only run at /app1.
Right. So yes, but for example, if you intercept request, there is no like cross-site restriction anymore, right? Like you can make requests to other websites directly from a service. Yes, so you're restricted to what you can intercept, but I don't think you're restricted to where you can send the request or from where you can fetch the data. It's fully I leave it to the web application designer, right? Because it's the same problem with any application, right? Like if you have local copy of a cache, how do you decide that you should show it and then update somehow versus wait for the new copy to arrive. So I don't handle it myself. I assume that if people use that library, that they want whatever the last state was completely.
Hey, so you mentioned that you've done a lot of work with Angular, obviously, in performance, and you talk about kind of web workers, service workers. Is there any we can say that Angular 2 is going to take better advantage of all these things inherently? How have you gone about trying to leverage all these things? Have you kind of had to force it on Angular? Because you kind of implied that like you tried, but then kind of it was a struggle. How do you get the best of both worlds?
So the best of both worlds was, I've done like a little thing of just running the Angular digest cycle in a web worker, right? But that's huge by itself, not the full framework. And by showing it at ngConf, Google had to admit that they're actually working on running Angular, like rewriting Angular 2, so it takes advantage of web workers, right? And people are like, so Google, when? Like, and they're like, yeah, it will run. So now it's running. Angular 2 is running in a web worker. Now the question is how the service worker, comes into the picture. So Google team formed a group that is looking how to leverage service workers for web apps. I don't think they came with any conclusions just yet and have not published anything. The person from Google probably knows more or can ask. I don't know. I think this is at the point where it will be some kind of data and UI caching first, right? And how a framework can take advantage of that is still up in the air, and I have not seen any implementations. I don't. So one reason is adoption, right? Even we limit our web app to Chrome and latest browsers because we cannot guarantee, right, that there will be a service worker. We cannot take full advantage of this. And creating a hybrid fallback support seems like will be too much to handle just for user to have instantaneous page. So
No, not too much. No.
Not too much. But if I were not here, maybe I would have done it. But because I like to share, the first, kind of spoils of this technology, I didn't have time to actually put it in production. Because we are busy writing our website in React, so we are the UI thread of our, organization. So we're busy doing something, so we cannot